The National Electrical Code, or NEC, does not explicitly specify a minimum height from the floor for all electrical components. However, industry best practices and specific equipment requirements often dictate installation heights. For electrical components mounted on a wall, a general guideline suggests a minimum height of 18 inches from the floor. This height helps prevent accidental damage from cleaning equipment or flooding and provides easier access for maintenance and inspection. When installing electrical components on a ceiling, a minimum height of 8 feet from the floor is commonly recommended. This height ensures adequate clearance for personnel and equipment and helps prevent accidental contact with live parts. For electrical components mounted on the ground, a minimum height of 6 inches from the floor is generally advised. This elevation helps protect the equipment from moisture, dirt, and physical damage. However, it's crucial to understand that these are just general guidelines. Specific applications and equipment types may have different height requirements based on their design, function, and environmental conditions. Firstly, disconnect switches and circuit breakers controlling equipment are often required to be readily accessible. The NEC defines readily accessible as capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. Secondly, equipment located in hazardous or damp locations may require higher mounting heights to prevent exposure to flammable materials or water. Thirdly, control panels and motor starters may need to be mounted at a specific height to facilitate operation and maintenance. Moreover, the Americans with Disabilities Act, or ADA, establishes accessibility guidelines for electrical equipment in public spaces. The ADA requires that operable parts of electrical equipment, such as switches and outlets, be mounted within a specific reach range to accommodate individuals with disabilities. It's essential to consult the ADA standards and local building codes to ensure compliance with these accessibility requirements. When designing and installing electrical enclosures, it's crucial to consider the environmental conditions of the location. Enclosures should be rated to protect the electrical components from moisture, dust, corrosion, and other environmental hazards. The enclosure rating, such as National Electrical Manufacturers Association or NEMA rating, indicates the level of protection provided by the enclosure. Proper grounding and bonding are essential for electrical safety and code compliance. Grounding provides a path for fault current to return to the source, while bonding ensures that all metal parts of the electrical system are at the same electrical potential. The NEC specifies the requirements for grounding and bonding in Article 250. The size of the grounding and bonding conductors is determined by the size of the overcurrent protection device in the circuits. Overcurrent protection devices, such as circuit breakers and fuses, protect the electrical system from overloads and short circuits. The NEC specifies the requirements for overcurrent protection in Article 240. The size of the overcurrent protection device should be selected based on the ampacity of the conductors it protects. Conductors must be protected against overcurrent in accordance with their ampacities as specified in NEC tables such as 310.15b16. Wiring methods are the means by which electrical conductors are installed and supported. The NEC specifies the allowable wiring methods for different applications in Chapter 3. Common wiring methods include rigid metal conduit, electrical metallic tubing, and non-metallic sheathed cable. The choice of wiring method depends on the location, environment, and type of electrical system. Conductor ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC specifies the ampacity of conductors in tables 310.15b16 and 310.15b17. The ampacity of a conductor depends on its size, insulation type, and ambient temperature. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Electrical panels are enclosures that contain overcurrent protection devices, such as circuit breakers and fuses. The NEC specifies the requirements for electrical panels in Article 408. Electrical panels must be readily accessible and properly labeled. Raceways are enclosed channels designed to hold and protect electrical wires and cables. The NEC outlines the requirements for raceways in Article 300. Raceways can be made of metal or non-metallic materials and come in various types, including conduit, tubing, and wireways. Firstly, conduits, such as rigid metal conduit, intermediate metal conduit, and electrical metallic tubing, offer robust protection for conductors in various environments. Secondly, cable trays provide support and routing for large quantities of cables in industrial and commercial settings. Thirdly, wireways, including both metallic and non-metallic options, offer a versatile solution for surface-mounted wiring applications. Selecting the appropriate raceway requires careful consideration of factors such as environmental conditions, mechanical stress, and electrical requirements. Metal raceways offer superior protection against physical damage and electromagnetic interference, while non-metallic raceways are corrosion-resistant and lightweight. Proper installation techniques are essential to ensure the integrity and safety of raceway systems. Junction boxes and pull boxes are enclosures used to connect and protect electrical wires and cables. The NEC specifies the requirements for junction boxes and pull boxes in Article 314. Junction boxes and pull boxes must be accessible and properly sized. Junction boxes are enclosures where electrical conductors are joined or terminated. They protect connections from environmental factors and prevent accidental contact. Pull boxes are larger enclosures used to facilitate the pulling of conductors through long raceway runs. They reduce strain on conductors and simplify installation. The sizing of junction boxes and pull boxes is critical for ensuring adequate space for conductors and connections. NEC Section 314.16 provides guidelines for determining the minimum size of junction boxes based on the number and size of conductors entering and exiting the box. Pull box sizing is governed by NEC Section 314.28, which specifies requirements based on the raceway size and the angle of the pull. Terminations and splices are the points where electrical conductors are connected. The NEC specifies the requirements for terminations and splices in Article 110.14b. Terminations and splices must be made in a manner that ensures a secure and reliable connection. Firstly, wire connectors, such as wire nuts and terminal blocks, are used to join conductors together. Secondly, splicing methods, such as soldering and crimping, provide permanent connections between conductors. Thirdly, terminations must be properly tightened to ensure a secure connection and prevent overheating. Proper torque is essential for ensuring reliable electrical connections. The NEC requires that terminations be tightened to the manufacturer's specified torque using a calibrated torque wrench. Over-tightening can damage the conductor or terminal, while under-tightening can lead to loose connections and overheating. Labels and markings are essential for identifying electrical components and circuits. The NEC specifies the requirements for labels and markings in Article 110.21. Labels and markings must be durable and legible. Firstly, circuit breakers and fuses must be labeled to indicate the circuit they protect. Secondly, electrical panels must be labeled with the voltage and amperage of the system. Thirdly, equipment must be labeled with its voltage, amperage, and horsepower rating. Arc flash is a dangerous electrical hazard that can occur when a short circuit creates an arc of electricity. Arc flash can cause severe burns, injuries, and even death. The NEC requires that electrical equipment be labeled with arc flash hazard warnings. Personal protective equipment, or PPE, is essential for protecting workers from electrical hazards. The NEC requires that workers wear appropriate PPE when working on or near energized electrical equipment. PPE includes items such as gloves, safety glasses, and flame-resistant clothing. Coordination studies are used to determine the optimal settings for overcurrent protection devices. A coordination study helps to ensure that the overcurrent protection devices will trip in a coordinated manner to minimize the extent of an outage. Selective coordination is a design approach that ensures that only the overcurrent protection device closest to a fault will trip. Selective coordination helps to minimize the extent of an outage and improve system reliability. Maintenance and testing are essential for ensuring the continued safety and reliability of electrical systems. The NEC recommends that electrical systems be inspected and tested on a regular basis. Maintenance and testing should be performed by qualified personnel. Infrared thermography is a non-destructive testing method that can be used to detect hotspots in electrical equipment. Hotspots can indicate loose connections, overloaded circuits, or other problems. Power quality is a measure of the quality of the electrical power supplied to equipment. Poor power quality can cause equipment to malfunction or operate inefficiently. Power quality problems include voltage sags, voltage swells, and harmonic distortion. Harmonic distortion is a type of power quality problem that can be caused by nonlinear loads, such as electronic equipment. Harmonic distortion can cause equipment to overheat and malfunction. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. The NEC requires that SPD be installed in certain locations to protect sensitive electronic equipment. Emergency power systems provide backup power in the event of a power outage. The NEC specifies the requirements for emergency power systems in Article 700. Emergency power systems must be capable of providing power for essential loads such as lighting, fire alarms, and life safety equipment. Standby power systems provide backup power for non-essential loads in the event of a power outage. The NEC specifies the requirements for standby power systems in Article 701. Standby power systems can be used to power equipment such as computers, refrigerators, and air conditioners. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. The NEC specifies the requirements for renewable energy systems in Article 690. Renewable energy systems must be installed in accordance with the NEC and other applicable codes and standards. Energy efficiency is an important consideration in electrical system design. The NEC encourages the use of energy-efficient lighting, motors, and other equipment. Energy-efficient equipment can save money on energy bills and reduce the environmental impact of electrical systems. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock. The NEC requires that GFCIs be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCIs detect ground faults and quickly interrupt the flow of electricity to prevent electric shock. Arc fault circuit interrupters, or SIs, are devices that protect against electrical fires. The NEC requires that SIs be installed in certain locations such as bedrooms and living rooms. SIs detect arc faults, which are a common cause of electrical fires, and quickly interrupt the flow of electricity to prevent a fire. Lightning protection systems protect buildings from damage caused by lightning strikes. The NEC recommends that lightning protection systems be installed on buildings in areas with a high risk of lightning strikes. Lightning protection systems provide a path for lightning current to flow safely to ground, preventing damage to the building and its contents. Electrical safety is paramount in all electrical work. Always de-energize circuits before working on them. Use appropriate personal protective equipment, and follow all applicable codes and standards. When in doubt, consult with a qualified electrician. They can provide guidance on specific code requirements and best practices for electrical installations. The specific rules for electrical installations are subject to change, so it is important to stay up to date on the latest edition of the NEC and any local amendments. In Florida, local building codes may have additional requirements or interpretations of the NEC, so it's always best to check with the local building department. Remember, working with electricity can be dangerous, and it's always better to be safe than sorry.